Welcome, everybody. This is our fifth Arctiq Backstage event. Welcome. Today I've got Phil Thomson, Shea, Stewart, Aaren, Jong on the line here. And today we're going to be going through some Arrow and some really cool demos and deployments are going to be waiting for you. So without further ado, here is the intro to our talk. Really quickly, I just want to share with you all my one application here. Sorry about this. And really quickly, today's topic is going to be a little bit different than what you may be used to. So in the past, we have been doing a bunch of Anthos-related events and focusing purely on Google Cloud Anthos. So today we're going to be doing things a little bit differently, and we're going to be talking about Azure Red Hat OpenShift, specifically Arrow. And with that, it's going to be a fun little new dive into what we have been doing with Microsoft and Red Hat, and talk a little bit about what they're offering and how we've been integrating with them with some different solutions from third-party vendors and their ecosystem. So just a quick intro to the team here. I've got a few people on the line. Let me just bring them up on the screen really quickly. There we go. And today, we're just going to talk about, I'm going to talk about Arrow really quickly and what Microsoft and Red Hat have been offering for the last little while. The topics for today are going to be a little bit about the technical aspects of how to use Arrow and why we should be using Arrow as opposed to a customer managed OpenShift instance. And then at the end of the session, we're going to cover some Q&A. So if you have any questions, please feel free to jump into the YouTube channel and just enter in some comments and questions and ask us there. It's all live chat. So we're happy and looking forward to some questions that we can answer for you. At the end, if there's any questions that we haven't asked, we'll definitely do a Q&A session. And then at the very end, we're going to bring in a special guest from Red Hat that we'll keep him secret for now. He's a very well-known and influential part of Red Hat on the Canadian side for delivering OpenShift and Red Hat products to customers. So with that being said, I'll get right into it. Really quickly, just because this is the traditional thing you say on YouTube, please like and subscribe our videos if you're into it, and hopefully you enjoy. So without further ado, today is, again, it's about Arrow, and if you're not familiar, it's about Azure and Red Hat OpenShift. So that's where Arrow comes from. And it's really about this relationship of these two friends that have been working so hard, specifically and especially this year, releasing this Arrow product that is very influential to customers who want a very managed infrastructure and offering without so much overhaul and work required on the customer's end to manage infrastructure. So Arrow looks something like this, where you've got Red Hat and Microsoft that are going to be helping you deploy OpenShift in Azure's cloud platform, Microsoft's cloud platform, and you get to mainly focus on just your applications, just your namespaces and the OpenShift application-specific things, where you can rely a little bit more on Microsoft and the cloud to handle the platform itself. Okay, so what does that look like in a traditional sense? You've got OpenShift. If you were to deploy it on Azure yourself, where you're going to be handling more of the infrastructure yourself, then the responsibilities rely a lot on the customer, where you've got to handle all the application stuff. But in addition to that, how are we deploying the cluster? How are we handling monitoring and logging? But also, how do we just do any sort of platform infrastructure related things, whereas you still have the platform deployed on Azure, and you're using Azure VMs, or you're using all the OpenShift API and SDN. That stuff is still a little bit heavy in terms of management on the customer end. With Arrow, you could do it this way, where, yeah, it's a little bit more managed. You've got the cluster creation piece, the monitoring and logging pieces, network configurations, and software security updates, that's all being managed by Microsoft and Red Hat in conjunction. And you can just focus on your, OpenShift application lifecycle, user management, and setting up project quotas and limits and things like that. So from a high-level standpoint for the customer, it really looks like you're getting that really nice, influential, managed support from two really great partners, Microsoft and Red Hat. And if you have any sort of support issues, you've got 24/7 support with them, ISO compliances, and they're working together on this. So if there's any sort of support that you need, any tickets you want to open, you have the ability to do that through the Red Hat portal and the Microsoft portal, where the teams are working together to ensure that you're getting a consistent experience on Arrow, on Azure with OpenShift. All right. So without further ado, let's get into the actual topics for today and the demos for today. So today we're going to start off with Phil Thomson. He's going to be talking about GitOps and the automated Arrow deployments. Then we're going to follow up with Shea Stewart. He's going to be doing the day 2 ops with Azure Monitor. And Aaren is going to be covering some Sysdig and how we can use Sysdig with Arrow. So without further ado, let's dive into that. And I'll just quickly get these guys in here. And you're live, Phil. So here you go.
Excellent. Thanks, Chris, for the intro and getting us going there. Let me get this presented. Alrighty. So I'm going to be looking at sort of the deployment of Arrow. So getting Arrow up and running and wrapping GitOps around that, just so we have kind of an automated way to deploy Arrow, and we've got some controls around it as well. So I've got a bit of a whiteboard screen to look at the process, and then we can see a demo so we can see it in action. So yeah, a bit about myself. I am a consultant at Arctiq. Sorry, I think the screen is not sharing the right one. Here we go. All right, so I'm a consultant at Arctiq. Focus on sort of all things OpenShift, DevOps, automation, containers. I'm lucky enough to work with a lot of clients in the OpenShift space. So we're talking about, deploying clusters, setting up, leveraging all the sort of ecosystem and the tools around there, and across sort of all different clouds. And if we come down here, and let me get this into a bit of a bigger view, hopefully. If you give me a sec here, I'm going to stop that and share my big window.
Yeah, maybe if you just hit present on that slide, this should be good.
Cool. Do you want to switch back to my screen there, Chris?
There you go.
Awesome. There we go. Cool. So this is just a bit of a whiteboard overview of the process. So if we're looking, we've got our sort of 3 containers here. So we've got our GitHub, we've got the Azure Cloud, and we've got Ansible Tower. So starting in GitHub, we've got our repository that's got our automation code. So we've written Ansible playbooks to help automate things. We've also got a variables file here that's defining our cluster. So it's going to have information about the size of our cluster, the networking information, all that's going to live inside of GitHub. In our repo, we've got a webhook. That webhook is talking to a corresponding listener on the Tower side. Inside of Tower, we've got our job that's pointing back to our Ansible playbooks and the project. We've got some credentials as well to authenticate to Azure. And then inside of on the Azure side, we've got our resource group that gets created to hold our Arrow object. And then we also get the resource group that gets created when we run the Arrow deploy. So that's a quick overview and of sort of, using GitHub to store credentials, to store variables, store a playbook, getting Tower to automate that process into Azure. And we can switch over to a demo here. So let me close that out. And I'm just going to stop sharing my screen and switch over to a video.
Video demo is definitely the way to go.
Yeah, it's pretty handy for sure. Making sure there's any issues with the demo gods.
Absolutely.
So I believe it should be this one. Sorry, just trying to switch it over. That's not the right screen. Okay,
so for those that don't know, I believe Phil's got about 8 monitors in his setup. He's a big fan of.
Yeah, the multi-monitor thing here makes things tricky when instead of sharing the whole screen.
Screen real estate is key.
Indeedy. All right.
I prefer the approach of doing the whiteboard without a screen. That was a nice way. A lot of teammates ask us, how do we do virtual whiteboards? And I think Phil just puts a camera on a whiteboard and then draws on it. I love it.
Yeah. Easy way. Alrighty. Got the video up here there, Chris.
Got you.
Awesome. Cool. So this is just looking at the Microsoft site, actually. So there's the Docs Microsoft site has a good walkthrough on exactly the steps involved for creating a cluster. So I believe right now it's just AZ using the CLI and the Aero extension to create the cluster. And on the Microsoft site, there's sort of individual step-by-step walkthrough to get your Aero cluster up and running and the prereqs for that. So these are some manual CLI tasks. We've kind of grabbed those and thrown them into a bit of a playbook here. Again, it's nothing complicated. They're just some shell commands right now. There is a Aero module coming for Ansible shortly, which will kind of clean this up. But for the time being, I believe it's just AZ commands now to deploy your cluster. So we've got that captured into our playbook inside of GitHub that creates a cluster. Now for talking about GitOps and doing kind of the automated process, we want to create a new branch off our main Aero cluster branch. So this would be the process you would go to deploy a new cluster. So this would, if there was a developer maybe wanting a quick cluster up and running, or maybe a new production or dev environment, would be the process. Inside this variable file I talked about, we've got all the information needed for our cluster. So again, there's some secret information inside of Aero, has some tight integrations with Azure. So when you're deploying virtual machines or storage, it's actually your Aero cluster doing that sort of for you on your behalf. So there needs to be some a service account or an SP account inside of the cluster that's got those credentials, so it can talk back to Azure and do that. So you can do that sort of during the process, the AZ Aero create command, or you can do that kind of beforehand and then provide those credentials in. If you've got some sort of enterprise process to create an SP in Azure, I suggest doing that. And then also when you run the automation, you need to run as someone. Again, that would preferably be a service account, not an individual user's account. So you would create generally, create a service account for Tower, your automation tooling inside of Azure, and give that credentials to allow it to create things. And that way, your normal users have restricted access. And then inside of this variable file, we've got location for our cluster, name for the cluster, the number of workers, network information if it's a private or public cluster, the size of our worker nodes. So all these can kind of be customized depending on what you want your cluster to look like.
And so just to be clear there, Phil, you don't want people writing directly to master branch?
Correct. As easy as it is. It's nice to, definitely create we've got a feature branch here, and then we create add another branch off there, and we merge back into it for sure.
Cool. How would you, separate your different customer environments between, let's say, like a dev and a non-prod cluster? Is that something you would want to separate per branch or in a different directory?
Yeah, for sure. So there's a few different approaches. Definitely, you can create either several branches. You can have like a prod, dev, like pre-prod type branches, and manage files that way. Different folders works as well too. There's also different separate repos as well. One of the things you'll find with GitHub is that it's a webhook per repository. So if you do take the approach of having, say, multiple folders or multiple branches in the one repository, you're gonna the webhook's gonna trigger regardless of the branch it's for, and then you kind of need to do some filtering on the sort of receiving webhook side to look for what branch it's coming from, and then do a thing or don't do a thing, which actually I'll show you here shortly. So just going through updating this variable file, and we can kind of commit that to our demo branch. Once it's committed, we want to go through the normal GitHub pull request process. So we want to, merge our changes back into the Aero cluster branch, have someone go through and check the files that have changed, make sure they make sense, make sure there's someone there is appropriate to review and improve the process. Again, like I mentioned, this could be used for maybe a developer who wanted to create a cluster just for like a week or two. Again, this is a pretty quick process. So they go through and set this up, create their own file. They'd have access to GitHub, create their own variable file, create a pull request, and then, select maybe an ops team member somewhere to review that file to make sure that the variables they had make sense and that's gonna work. And then again, once the files have been checked and we create the pull request, you can go through, make sure it makes sense, and then we can merge the pull request. When we merge that pull request, it obviously, because we've got the webhook set up and some automation here, that's going to trigger a webhook call on the tower side. We've got this variable too to create destroy. So we're using this just to flag either, we're using these variables to create a cluster, and then the opposite, when we want to come back, we set that as a destroy. So when the cluster's all done, we're done with whatever we were doing in the cluster, we can then flag it as destroy, run the automation again, and it's going to go and clean up our cluster, which I'll show you sort of the deprovisioning process once we've got one up and running. So we're merging that pull request in, and we'll jump over to Tower, and we'll see the job that would have got triggered. Cool. So we can see our running job there. Again, these are just going through all the steps that are listed in that Microsoft doc. We're logging into Azure. We're actually removing the extension just to make sure we don't have an old one, so that Aero extension to the AZ CLI does get updated frequently. We just want to make sure we've got the latest one in there. So we just remove it, then we add it back in. So we've got the latest one. Obviously, we just want to set the subscription, register Aero to the sub, and then we're creating a resource group to house the OpenShift object and creating some network information.
Beautiful. So I guess one question I had a little bit back in the GitHub side, how would you handle the permissions requirement so that not anyone can just go in and create a cluster on the fly? Like, how would you prevent, or what would be the best approach for somebody to prevent non-administrators or ops people from merging to the master branch, for example?
Yeah, for sure. So you definitely want to put some branch protection on your master branch or your core feature branch. So like the Aero state of deploy or Aero cluster branch. And then just to make sure that, it does require a pull request in order to get code into that branch. And then you want to stick some permissions on the repository itself. So you maybe want to flag a few admin type people that can approve the pull requests. And then you can assign, maybe your whole organization or a group of people inside there edit permissions, so they can go and, they can update files, but they can't approve pull requests. So they could open up pull requests, but not approve them. So that's definitely a good approach. You want to make sure you're doing that. Then jumping back here, we can see the last step is just to create the cluster. This does take a little while. It's probably, 45-minute, an hour type thing in Azure. So if we jump over and look at the job template while it's kind of deploying our cluster, nothing crazy complicated. We're running against localhost because we're obviously not connecting to VMs. We're just running against local Tower. We do have those credentials stored as secrets inside of Tower that are encrypted, which is nice. So we've again got the SP that the cluster is using, and then the SP that we're running the job as. And then we've just got we're pointing at a create destroy, kind of a selector playbook, I like to call it, which we can jump over and have a look at. Something to note too, if you're running this in Ansible Tower, you might need the AZ CLI, so you'll need to create a Python virtual environment, add that Azure CLI in there in order to run sort of a playbook that's leveraging it. So yeah, jumping over and looking at the selector playbook. So this just has a few when statements to kind of determine what playbook to run. Again, it's looking at that create destroy variable to see if it's a create or destroy, and it's going to run the appropriate playbook. And it's also looking in the that tower webhook payload.ref. Inside that, that's all the information that comes from our webhook. So we're looking for a cluster in this case, so to make sure that we're looking at the right branch. But this is where you would do some like a sort of filtering on the webhook side to make sure it's coming from the right branch. And obviously, if none of these when statements match, it's just going to skip and not do anything. So those are pretty handy to have in there. And we're also pointing out a specific variable file as well to run our playbook against. So if we come back here, I believe like still, looks like we're all finished. The power of video and time warping. Our playbook's done. You can see we've skipped over the destroy steps. So if we go over to Azure, we can see we've created 2 resource groups here. So the Aero Demo 01 resource group, that's hosting our VNet and as well as the Aero object. So that's all we really see here. This resource group's handy for putting things related to the cluster as well too. Things like a Postgres database, some managed database service, key vaults, things very specific to that cluster. And you can see we've got a dynamically generated cluster ID resource group name here. You can set that to something specific if you wanted to, or you can just have it dynamically generate. That'll make sure that it's not overlapping and you're not going to get an error about the name already in use. So for visibility in Azure and AR, you can see kind of all the OpenShift objects that makes up in Azure, that makes up the cluster. You can't really do anything here. You can't turn off VMs or edit things or modify storage. You'll actually get some permission denied errors. So it's good to see kind of what's in your cluster, what's making it up. You can see the disks that get created for PVs. Good visibility, but again, you can't actually do anything in there. You'll just get some access denied errors. Once the cluster's up and running, you can use the az-arrow command to kind of spit out some cluster information so you can get your console login. And then as well too, you can get your kubeadmin, so the root password to your cluster. So you can kind of log in the initial login, that root user, and then set up your OAuth credentials or some way to authenticate to the cluster. And go through all those post configuration tasks.
I guess that's kind of like one of the pros and cons to it, having that managed cluster, not being able to actually log into the machines and make your own little changes that a lot of sysadmins may want to do, but we know we probably shouldn't, just like we shouldn't really be SSHing into or logging into our pods and containers.
Yeah, you got it. Yeah, it is, again, for there's some storage information you could potentially see from inside of Azure, the console, that it's a bit more locked down. But again, I think that overall, maybe some lack of flexibility there about modifying things, but I think that comes at a greater good about people tampering and touching with things. I think, I don't know what the percentages of how many things break in production is due to some ops guy trying to fix something and hit the wrong button. So yeah, having that kind of permission removed away is definitely, I think, beneficial. Alrighty, so that was kind of deploying the cluster. I can go through kind of the destroy process now. So very similar, just kind of reversing that. We're just gonna, again, toggle that variable from a create to a destroy. Again, do that pull request. You'd flag the right person reviewing, and then merge it. And then once that gets merged successfully, it's gonna trigger our automation to run. Excuse me. All right, so there's our our playbook kind of running. Again, similar, the destroy process is very similar to the create. The first bits are all the same about logging into Azure, setting the right subscription, and then running the az-arrow destroy. So we can see we've got 31 objects in there. If we just give it a refresh, we're down to 28 there. So yeah, so we can see the playbook has gone through and it's destroying objects now. Again, that takes a bit of time, a little shorter than the deploy process, but it does take some time to clean that all up. And again, using that resource group will get created to store the OpenShift object. Again, you'll have some things here, potentially some managed Azure services that may want to stay around. So generally, we'd hang on to this resource group, just confirm there's nothing there, and then go and delete it. And then that would be the the final step to clean up your Arrow deployment. You'd have your dynamically created cluster resource group gone, and then this one gone as well too. Perfect. So that is just the process of deploying a Arrow cluster via automation and using some GitOps approach in there. So again, we want to kind of automate things as much as possible. We also want to have some approval process and make sure that there's some change history in place. So using GitHub, we can see who's committed files, who's approved it, and that whole sort of audit history there, which is great. And I'm just going to stop the screen share and switch over. Awesome. I got one more screen to share here. I was just going to go through. So we want to go to this one here.
So Phil, just out of curiosity, in your experience, are you seeing Git, sort of the GitOps method of just actually creating a feature branch and applying that being the front door that teams are using to provision these clusters, or are they kind of integrating that with some other system?
Yeah, for sure. So yeah, we've definitely seen some teams take, GitHub as the first approach. Again, GitHub can be new to some people, especially ops guys or maybe, management type people in the team that are looking for some clusters. So there's the other way we've seen it done is sticking in, like you mentioned, like another front door on top of that, which may be ServiceNow. So there could be, if ServiceNow is tightly integrated to the organization, there could be a ServiceNow form created, like create cluster form that they'd fill in, have some approvals on there. And that ServiceNow then would, write to GitHub, potentially store that variable file, and then would also talk to Tower 2 to trigger the automation. So we've seen kind of that approach as well.
Alrighty, I'm gonna bring you back into your stream here.
Excellent. So one of the other things I mentioned is, once your cluster's up and running, you've got a bunch of other, post deployment steps to go through and configure. That's kind of the starting point to getting your Arrow cluster. You want to, log in, make sure, do a bit of a smoke test, things are operating, and then you'd probably want to come through and start configuring it. Things like setting up the OAuth if you're authenticating to GitHub or maybe using Azure AD. There's a bunch of configuration needs to happen. One process we've seen is using ArgoCD, which is now, it's an operator inside of OpenShift. So it's easy using the operator hub to install ArgoCD. And then ArgoCD's kind of main purpose in life is just to point it back to a GitHub repository that has Kubernetes and OpenShift manifest files, and then ensure that those manifest files are applying. So again, that's the whole GitOps approach and making sure GitHub is, or your Git repo is your single source of truth. So something we've done is you can store your cluster configuration inside of there. So you can create a folder inside of your repository. So a folder per cluster, and then you'd store all your cluster configuration as YAML files, OpenShift files, and then have Argo apply them. So you'd create an app in Argo that would constantly kind of search here and adjust it. So, things like your OAuth config, you maybe want to store this here. This would obviously, pointing back to your Azure AD in this case, but maybe something else. It's obviously using some secrets, so there's nothing kind of credentials stored here, as well as like some auto scalers. So again, the cool thing with OpenShift 4 and Arrows, you can kind of auto scale it. So we can have a maximum, minimum of clusters about 1 to scale, which is great. So storing all your configuration here and letting ArgoCD synchronize it. Again, that single source of truth, if someone goes through and, wanted to modify the cluster autoscaler to say, maximum is, 2,000 nodes in the cluster. That process would be, if they had the right rights in OpenShift, they'd be allowed to do that. In this process, if they want to change that in OpenShift, ArgoCD would actually change it back to make sure that the source of truth is pointing into GitHub. And then if they did want to change it, they'd have to come through that process of coming through, creating a branch, adding the modified file that they wanted to make changes, getting someone to approve the pull request, and then once that's approved, and then Argo would go through and synchronize it. So that's a handy approach, kind of using some GitOps and some other automated tool to get configuration changes into your OpenShift cluster, which is handy. And I think that's it for me. Yeah, just a quick quick overview for deploying, using GitOps to deploy your Aero clusters. And if there's any questions, yeah, just shout out in the chat window there, and I'll try and get to you.
Awesome. Thanks a lot, Phil. Oh, there we go. Okay. One really quick intro that I want to do, a little bit different than what we're used to. We usually have our special guest coming in at the end of the event, but we've got him here extra early because he wanted to participate. So allow me to introduce Michael Cardy here. He's got a little bit of background noise, but that's okay. Michael is a chief technical strategist at Red Hat in Canada. He is here today as our special guest to just talk a little bit about Red Hat's strategy for OpenShift and Arrow and all things Kubernetes and automation. And so welcome, Michael. We're going to do our Q&A a little bit later, but I'm happy to have you on board just to provide some comments and feedback.
Well, thank you so much, Chris. Thanks to Arctiq for having me. Really appreciate all the details and in-depth presentation I've already seen from Phil. Very, very intriguing. And I'm very happy to be part of the broadcast today. Thank you.
Awesome. And without further ado, let's move into Shea's piece. So next up, we've got Shea Stewart. And this is around Arrow Day 2 Ops with Azure Monitor.
Thank you very much, Chris. So I guess you're driving my slides. I'm Shea Stewart, partner at Arctiq. We've been doing OpenShift for a number of years. I really think since the early sort of OpenShift 3, 3.0, 3.1 days. And it's really interesting to see how it's evolved and the strategy of Red Hat and how it's evolved for sort of enterprises to capture this, what I would call unique sort of developer first toolkit around Kubernetes, but then how it's moved into the hyperscaler cloud infrastructure space as well as enterprises start to move away from owning so many data center infrastructure components themselves and transitioning certain workloads into hyperscaler clouds such as Microsoft Azure. Now, it's been interesting to watch co-developed managed techniques with something like Microsoft that helps the enterprise reduce the burden of their operational management, because these things are hard, right? Kubernetes is not a simple platform, and OpenShift tried to make it easier, but there's a lot of components. And so now we're going to talk about Day 2 Ops, but if Microsoft and Red Hat are doing that for us, what's left for us? And Chris, can you just go back or pass control over to me? Maybe just pass control over to me. That would be great.
There you go.
Thanks. So you've seen the two slides that I have. What I want to talk about first is Azure Monitor, and this is the OpenShift component to this is in public preview. So I'm going to show you sort of what I've discovered in the bit of time I've spent with it. But the idea around Azure Monitor itself, or Azure Container Monitor, is a service that's provided from Microsoft that can capture more than just your OpenShift container log data and metric data and components like that. So this becomes really important to an enterprise that has more than just OpenShift running in their environment, which is half the reason we often move these workloads to the clouds, is because we want them to be closer to other services that we're consuming from the cloud providers. So if we're doing things like, like SQL in the cloud or things like that, we need to be able to have a holistic view of everything that composes our application, not maybe just the OpenShift stack itself. And so what Microsoft has been doing is been offering up this service on the Container Monitor side that can now, in the preview side, tap into OpenShift, which is incredibly powerful. And really, this, from my perspective, comes along from the log sort of aggregation and querying and analytics side of things. I know Aaron's going to take us into some of the metric sides as well as we talk about the Sysdig component. So the second and last slide that I have, a little bit of what this looks like. It's just to kind of give you an idea that the Azure Container Monitor service not only taps into logs and log forwarding itself, but it also allows us to scrape and collect Prometheus metrics as well. So on the left side, you have a pretty typical Kubernetes environment where you would have Prometheus exporters configured. And those who have deployed OpenShift or any Kubernetes cluster are aware of like kube state metrics and the node exporters and things like that. But then we can put those into specific workbooks and put those into like dashboards and gain some insights as to the health of our cluster, but also as to the health of our other resources in comparison to our cluster. So that's it for slides. What I'd like to do first is kind of walk you into a little bit of the Azure experience from the portal. So Phil's already shown us building a cluster. And one of the unique things when we look at ARO is that, as opposed to sort of other managed services, would be that all the data and components around my cluster are actually shown inside of the dashboard. So I've got sort of this singular sort of portal experience, which is quite useful for anybody that's working in the Azure console day in and day out. We don't want to have to jump to necessarily another console. So if we take a look at our little OpenShift logo here, we've got our cluster. We've called it Columbia. Columbia, for those who don't know, in this context, would be a particular ship inside of Battlestar Galactica. It's not me misspelling a country's name. And when we click on it, we can see sort of a high-level overview of where my OpenShift console resides, the particular version. Now, as we've talked about, part of the ARO offering that's really, really popular here is I get things like automatic upgrades, right? And so those, if you jumped into a cluster that's been built on a previous environment, you'd actually see in the OpenShift dashboard a history of all the versions that it's been upgraded from. So I've got another customer we've gone through 3 or 4 upgrades, but the experience from an administrator perspective was that I didn't have to do anything. I just logged in and saw that and was notified that the upgrade had already taken place. Now, of course, we can discuss with our SREs when that should happen and how that should happen. But that seamless experience of upgrading my nodes or upgrading my OpenShift version is really, really powerful. So already the day 2 ops stuff is being heavily lifted away from sort of my control, which allows the SREs to do their job. Now, but that doesn't mean, when we showed before the slide of like, okay, so all I need to focus on is the apps inside of the cluster. That's not exactly true. We still have other components that we would like to layer into this cluster, things that might be relevant towards our business, or maybe we want custom alerts, or maybe we want additional metrics on all of the people using the cluster. It's not uncommon for an OpenShift cluster to be multi-tenanted. I mean, it was designed from the outset to have many, many tenants. And unlike other Kubernetes deployments that were often built as a specific cluster for a tenant. And so in this case, we need some level of visibility as to what our tenants are doing as well. And so this is where the metrics and the sort of log aggregation become really, really powerful. And so what we've done here is we've got our sort of standard portal integrated dashboard, but once you click out into that, we're going to just jump into our standard OpenShift 4.4 environment. Now, this operational view of the dashboard, if you're familiar with this, is going to give us sort of a high-level overview of what's going on in our cluster today, how many nodes we have, how many pods we have, all that sort of stuff. And so you've got a good grasp of what's going on at this moment for this cluster. And if I jump into the standard sort of monitoring dashboard area, you've got some sort of high-level view here, or we can jump into the Grafana UI that most people are familiar with. This has been around since the OpenShift 3. I'm going to guess around the 7 or 9 days was when the Prometheus and Grafana stacks started to get introduced. This is a great and powerful tool for a single cluster. And this is a great operational view for a single cluster, but what this isn't great for is either multi-cluster views of workloads across many environments, or it's also not great for giving access to our end users. This is mostly from an operational or day 2 ops sort of perspective. So a platform admin would have access to this, but maybe not a tenant. And so this is really useful. But as I move into my Azure space, and the reason I'm often putting my cluster inside of Azure is because I have other workloads there and I want to coordinate those together. I might have some VMs and some containers working together. This is one of the most common use cases that I see. As we moved away from developing greenfield applications, we moved into brownfield applications where we have maybe a database or a data resource that exists outside of the cluster, but I want to develop new components inside the cluster. And so how do I sort of get a consistent view out of all of this? So this is where Azure Monitor comes in. What you can see here, again, public preview, so I'm sure features are continuing to be developed. But what you can see here is the dashboard that comes with the container monitor from Azure. And I've already run the steps to register my Columbia cluster with this, and I'll show you what that looks like. There is also another opportunity that if you have unmonitored clusters here, then you can onboard them through the portal as well. But this is mostly driven from a shell script. And if we just take a quick look here, this is one large shell script. I'm not going to walk through it all. This is provided from Microsoft, but this shell script itself is actually what's used to bootstrap the cluster into the Azure Container Monitor service. And there's a couple of other things that I've done as well when we're building this out, which is I've created a dedicated workspace for all my log analytics to go into as well. So this is all just following the standard Microsoft documentation for these two components. It's very straightforward. Once it's been onboarded, you can actually see from this singular dashboard the health of my cluster or many clusters in my environment, the version, the number of nodes, things like that. And you're also going to be able to collect a bunch of metrics overview, a metric detail about the cluster. So we can get into pretty granular views if we wish to, but you can go everything from the cluster view all the way down to the container view. And what I actually really like about this particular view here, and this is maybe just myself, I'm a huge fan of 95th percentiles. We often talk about averages and we talk about maximums when we're sort of talking about the resource management of our cluster. But 95th percentile is often where things are really important. And so I like the fact that this is automatically built in, and this dashboard has been provided from Microsoft to give me a holistic view of everything inside of my environment and how healthy it is. And so what you can see here is this is every container inside of my environment, and you've got a few different metrics that we can select here, and then we can also pivot to the 50th percentile or the average or the min or the max. So you didn't have to set anything up in order to get this view. This was just us onboarding the cluster into the Azure Container Monitor service. Now, the question might be, well, what did that do inside of the cluster itself? So let's take a look quickly at what it gave us. I'm going to jump into overview, and I'm going to take a look at my pods actually. There's going to be two sort of components that we care about the most here. One of them is going to see a logging Azure project. And so this particular component inside of your cluster is running a different logging service than what OpenShift typically provides. So the OpenShift EFK stack is the standard component, and you could install that on top if you wish. And that would be a logging stack with Elasticsearch, Kibana, and FluentD all in one cluster. But the problem with that is that if you have multiple clusters, well, now you need somewhere to aggregate all of those logs too. And by using the Azure Container Monitor service, I've already got the FluentBit pods running as a daemon set inside of the cluster, and they're shipping out the logs from standard out or standard error out to this Azure service, which means then I have a big data analytics engine in the back that I can ask questions about and get answers. And so really I'm harnessing the service to do this at speed rather than having to run individual instances of my logging stack. The other component that's been deployed here is actually in our Cube system. And this is our monitoring agent. And what you'll see here is the RS pod itself. This is actually the one that has all the configurations attached to it. And then it is responsible for updating the daemon set and rolling out. So it's kind of like an operator, or is an operator, if you will, to manage all the daemon sets of the Azure monitoring agent. Now, if you have Microsoft Windows nodes as well, I believe that feature is coming soon. There is a daemon set this does install for Windows Kubernetes nodes. At this point, I haven't seen it on the feature list yet. So this particular component here is the one that's actually important for us as we integrate into the service. And what you can see is that we have quite a few different config maps, or a couple of config maps that are attached to it. And what those actually look like is something like this. Now, if you're going to follow the instructions on the Microsoft website to integrate this component, and you're hoping to get Prometheus type metrics out of this, and this is a thing I haven't mentioned yet, this will collect Prometheus metrics for you out of your cluster. So it's actually really, really powerful in that way. If you're going to follow the documentation is not exactly correct in terms of where the config map lives. This config map needs to live in kube system, because that is also where it's deployed the daemon set. And I believe the documentation references a separate namespace for this one. In addition, if you want to do things like collect the kube state metrics and the node exporter configurations, you're going to want to monitor or modify this particular configuration here. And this is because what OpenShift does is it adds some security onto the endpoints as far as Prometheus goes. And so what you're going to want to do here is, from a Kubernetes service standpoint, you can add kube state metrics as a scraping endpoint. And you're going to want to do this over SSL. That's one of the sort of important points here. And then if you jump down to the node configuration as well, this is the sample that they provide, but again, you're going to want to go to SSL. And what this is going to do is it's going to use the service account token that's embedded in the pod to curl that endpoint. And you're going to want to change the port here to 9100, because that's the way that OpenShift exports it as well. Once you've made those changes and the daemon set has been rolled out again, you actually can start collecting all of the Prometheus metrics as well. So you've got both log data and Prometheus metric data inside of the same log workspace inside of Microsoft Azure. So we've jumped through a little bit of the sort of container insight view, and you can tell the status of the components. And so this is a great sort of metric piece. But let's go ahead and also take a look at the log component as well. I think what I'm going to want to do is jump down.
Hey, meanwhile, while you're looking for that, Shea, just a quick question regarding, like, a lot of customers nowadays are probably going to have their own logging and monitoring solution, maybe on-prem, maybe on the cloud. What would be, I guess, the right scenario or way to sync all of your logs or metrics from OpenShift, your Arrow cluster? Would it be like a direct connection to the metrics on the clusters themselves, or can you actually get all the data from Azure Monitor and sync that into your own on-prem solution?
It depends. I would love the IT answer. It's always going to say it depends. Where I'm feeling that this solution is centralized around right now is that I would actually be sending all of my logs and metric data into Azure. It's very likely that the service will be cost effective enough and singularly managed in an easy way that it should be the one that's sort of aggregating everything. If you wish to copy those logs out of the Azure service itself, you might want to look at sort of cluster forwarding at the cluster level, or possibly you can configure the agent to do that on the Microsoft side as well. I'm not 100% sure. I haven't really had to go down that road yet, because the larger use case here is, well, I have more than just OpenShift running inside of Azure. I want to see all my logs together so I can build a bit of a story of what's happening with that application. And so if you're already using the Azure service, you're likely going to want to take advantage of this. And the reason being is it's so performant and doesn't require all of the sort of headaches that it comes with building your own large data lake on-prem. So most engagements I'm working with are people moving outwards and kind of pushing that type of workload into the cloud. So what I want to show you here just a little bit is when we selected logs, we can actually go ahead and jump down to, let's say, a Kubernetes service example query and start to look at some really interesting things here. So let's take a look at maybe billable per namespace. I'm going to try to shrink this a little bit so that hopefully looks a little bit better. So this is a pre-canned log query that's actually going to go ahead and break out my entire environment based off namespace and give me a breakdown of all of the sort of billable build size of logs inside of that environment. So this is already starting to give me insight into what namespaces are doing what. Now, of course, we can change what we're going to query, and we can add charts to this, and we can then go ahead and save these as our own customized queries. So in reality, I would say, as a customer deploys this, you would start by developing maybe 10 or 15 useful dashboards and queries, and probably that would suffice for the majority of your workload now, and sort of your needs of monitoring the environment. Now, I'm doing this in one single Azure workspace. However, there's another option here, which is you could have multiple workspaces. So you could almost create a workspace per tenant, and that tenant could have their own access control as well. So once the data and the metrics are inside of the system, at this point, it becomes a really, really flexible tool to understand all of your operational components or infrastructure components inside of the cloud. So that's sort of one of the pre-canned ones. The other one I wanted to show you here is something along the lines of, let's just take a look at what we've been able to collect from the Prometheus side of things. So this query this will tell us every metric that we're able to query inside of the system that we pulled up from the Prometheus environment. So you can see all of the cube state metrics now that based off that config map that I've applied before, I can now query these through the service and start to build dashboards based off of my Prometheus metrics as well. And so what we do often see people doing is taking their single instances of Grafana dashboards and starting to build one larger dashboard here across all the data sets that are feeding this Prometheus data in. I can keep scanning and going down and down and down, but you can understand that between the node exporter and the cube state metrics, there is a lot of granular data that we're pulling from the system. There's another thing we could do here based off of the fact that, if we're positioning this as a tenancy environment, we can also go ahead, and these are some of the examples that Microsoft provides, but we can build a chart based off that query that actually renders how much of the Prometheus data that we're collecting from each namespace, and then how we could sort of build that back as well to our individual sort of consumers or tenants of the system. Or I could do a couple of other things here where I could just go look for alerts. And I was using this quite regularly when I was having an issue sort of getting my Prometheus metrics inside of the environment. So here you can see sort of my log data and any sort of events tied to, let's say we've got a prompt scraping event here, right? And so absolutely you can see where it is, what container it's relating to, what the error is. So we've got, we're not able to kind of hit 9103 on 10.009. So, hey, we know something's not responding there. Maybe we can go and investigate. And these are the types of things that then I would maybe generate a custom alert on. And if we want to get a little bit more specific, you can also do quite useful filtering as well. So we could do something like, adding more layers of wheres and whens. Here I'm targeting a particular server to gather some Prometheus-related information about master 2 or anything that contains master 2. And another component here is that as I start to fill in the query utility, it will actually start to help fill in the options for me. And so this is really, really, really powerful as well. So I want to go like origin, right? It's going to start to auto-populate. So you don't have to be a master at the query side of things when you start, and then you can go ahead and save those and reuse them as much as you want. So, we've taken a look at the left-hand side here where there's a bunch of pre-canned reports. I've also sort of shown you that there's a way to get all your Prometheus data in here, which isn't as well documented. Isn't as well documented as it should be at this point in time, but it is easy, and you just need to make a couple of configuration changes there as well. And maybe the last thing that I'll show you is that there is a way to, let's say, hey, great, I've got this data, but I want to get some alerts and I want to put them into Slack. Well, the way that this is going to work, and I'll show you kind of what a very simple alert looks like. We've got an incoming webhook alert, and then we've kind of got some sort of like alert that says container CPU alert test. Okay, great. Well, what we actually needed to do there was build a logic app. So let's just see if I can find that. And so I built this little logic app. I didn't build it myself. Full transparency, I totally took the code from another blog. But this is basically an intermediary webhook logic app that basically receives the webhook from the alerting system on Azure Monitor and then sends it off into Slack. So you can customize it based off the type of alert and the payload and things like that. Or if you have a different system like Rocket Chat or some other sort of chat tools to help integrate this alerting system that can now alert based off your VMs in the cloud or alerts coming off your SQL instances and your OpenShift containers all at once. And so that is another really powerful utility inside of this entire sort of monitor solution, which if you are an Azure tenant or consumer, seems to make sense that it becomes the core source of your monitoring solution. So that's about what I had to share for you today on the Azure Monitor integration. I've played with it a little bit. I'm really interested with where it can go and the types of queries and dashboards that could be pre-canned to make more use of how OpenShift can actually integrate into that with multiple OpenShift clusters. I'm going to pass it back off to you.
Awesome. Thanks, Shea. I had one quick question around that. You mentioned, doing webhooks or using a Slack integration for sending alert notifications. Do you know of any other potential integrations there are right now for Azure monitoring? Like, for example, Microsoft Teams? Is that something that's available yet?
So the way that the alert worked here, let me see if I can, actually, let me go back into here and see if I can maybe find that again. Where did I configure that? Manage actions.
I know if it's a webhook, it would be a pretty simple integration probably.
Well, so you'd think so. And here's the thing being that when you do this, when you do a notification type, right, you can do a webhook, and I've configured this one here, called it Slack, right, configured that. Well, this webhook itself actually isn't calling Slack. This is calling the logic app I created. So it's possible. I didn't see sort of like Teams wasn't a dropdown inside of Actions, right? You get a secure webhook, a webhook, Azure function, or some sort of playbook, right? Or call the logic app itself. So in this case, this is an intermediary app that is basically is the webhook receiving it and then sending it off. So your logic app would be customized for something like Microsoft Teams. I haven't seen Teams as a dropdown specifically, where if you look at other monitoring solutions, usually on the notification type, there's a dropdown that says, hey, would you like Ops Genie? Would you like, PagerDuty? Would you like Slack? Would you like, that sort of thing? They're pre-canned. In this case, I think you've got to bring some of your own, but it didn't take me very long to find what that would look like. And once you understand the scripting language, I think you would just customize it. We've experienced the same thing when we integrate with Rocket Chat. We usually have to customize our incoming webhooks on the Rocket Chat side as well. But I did not see any other sort of, major components here because you could write anything you needed that would, fit into one of these buckets.
Gotcha. Alrighty. Thanks, Shea. And now we're going to move on to Aaren. All right. Aaren, are you ready?
Hey, how are you?
I'm great. How are you?
Good.
Am I running your slides, or do you want to run your own slides?
If you just share my screen, I can take care of it.
Here you go.
Looks good. Thank you. That's great. And thanks, Shea, for kind of opening up into this next piece. I think it works out well that we covered all of those pieces ahead of this one. I don't think anyone should really run a platform like ARO or OpenShift or any Kubernetes without any kind of monitoring. I think everyone would tend to agree with that. So what I've done is done another dive into Sysdig again, now in ARO. The last time I looked at Sysdig was in OpenShift 3 and in 4, and not much should change when we're looking at ARO, but we have to remember a couple pieces. And I'll sort of talk about some of those and also show a little bit of the platform. So who am I? I'm big on open source stuff, and I like the concept of infra as code, using cloud tech And of course, it's the business we're in. We like to help people that use those things. So we're thinking, why Sysdig maybe? Uh, the tools of yore, and I did use that word, kind of like thinking about the Zabbix or the Nagios. They don't necessarily cut it with Kubernetes workloads because they're not native or even aware of the Kubernetes API and the other things that happen on hosts. And the biggest difference now is that we're focusing on with OpenShift 4 and ARO 4 is now the underlying operating system is not typical Linux, it's CoreOS. And while it's still Linux, it's very much of what's happening in there is different. You can't simply jump into the machines like we were more accustomed to in OpenShift 3, install agents, and then send all of their data out of the cluster without considering what it could do to the cluster. CoreOS is much more like thought of as like an appliance, and we don't want to change what the appliance is doing. It should be thought of as a more or less a closed box. So in the same vein, when you're talking about alerting, um, typical PagerDuty and apps like that are more accustomed to um, common virtual machine infrastructure. It has some capability in this area, but not all the same hooks into things. And I don't mean anything against these tools. They're great at what they did for what they do, but we have better tools now, and we need ones that are more focused on Kubernetes workloads. So being more Kubernetes API aware. And as for the Azure tools that Shea was talking about, they get to a certain level, but then there's more that you can layer on top because there's much more metadata that comes out of um, uh, the cluster and the nodes themselves. So I'll get into it right now and show you what I've got going on here. So in the same cluster, I threw in our random beer Giphy app, and I'm gonna just open it up just to show that it's there. It's doing what it should do. And I'm going to jump in and toss this into, let's have some fun here. That link is now up on our YouTube chat, and feel free to just jump into that address. You should be able to reach it. This should be a little bit exciting if we have enough people hit the link and start refreshing. It's fun to play a little bit risky once in a while. And what it's doing is I've scaled this up to a number of pods. So right now my count is at 7 pods, which I think is more than enough. It's a very light application, but I'm just trying to generate some load. Um, we have had this running for a little bit of time, and the thing about Sysdig is once it's installed, it does a lot of work to graph out things, and it goes beyond what you see in Grafana because it's meant to be much more long span time series of data, and you get to see what happens live. So I have a few different views to go through here. I've gone through the installation, which by the way is now going to be a little bit different from the way we used to because you have to make the decision of whether you want to use the eBPF specific scraping tool or if it's going to work with the current kernel scraping that it typically would use. The kernel scraping is what it used back in OpenShift 3, and things will have changed a little bit now that we're using CoreOS underneath the cluster. But there's a number of really interesting views that you can dive in to look at metrics. And I look at this platform as it's really interesting because it's got probably the most effective way of gathering all of this data and aggregating it and showing it to you in more graphs than you can throw a stick at. And I know lots of people really like pretty graphs, but aside from the pretty graphs, you get a lot of control and very quick ways to really drill down. So it's not one of those things where, I see a 5,000 foot view of current state metrics. What are my top consumers? Where are my resources going? If I go to the right view and I have a lot of tabs just to kind of gather what I'm trying to show, but I'm going to pick on one particular thing. So we'll see if we've garnered any activity on the applications. Let me just drill into it.
I just posted the link in the chat as well, if people wish to try to hit it.
Was that not there the first time I dropped it in? Oh well. Okay, so yeah, so we have some activity on this one. I'm gonna just try to drill down into the specific one. Our beer Giphy app, I put in a namespace called cold because we like them cold. And so beer Giphy pod availability. So what we have here is there's a lot of different dashboards that just come right out of the box. And I like that because it makes it easier to just right off the bat. Like what you see here for Kubernetes is everything that comes with the platform right off the bat, and you don't really need to build these custom right on your own. You can dive into these and start using them right away. And this is a SaaS model, by the way. And there's a couple other things to see. So here you can see if I could look at my time span for the last minute, and we could see core usage has probably shot up for random B or Giphy, which makes sense. And that's just for the last minute. But if I go further to like the 12-hour mark, and we look at when I was testing this deployment last night, and then we can compare to what's going on this morning. If I'm looking at a large span and I want to drill down, I love how all the graphs are synchronized, and I can just kind of select right here, like the top 50 memory usage by pod, and it'll zoom into that one section that I'm concerned with, which happened at 2:30 a.m. And that's totally fine. We don't get a lot of sleep in this industry. So then from here, I can continue to drill down. And while I just see a metric, I can turn this into some actionable items by just looking at this thing and creating an alert. Or I could export the data into various different formats, but I could create alert based on a number of different metrics. And these alerts can get pretty crazy. So in advance, what I did is I took one alert related to CPU usage, and I set it to something really low, like 3%, because it's very difficult to kind of, I guess, drive a whole bunch of traffic without anticipating for whether people hit the address or not. So I set it really low to like 3% just to show what this alert looks like. And it gives you quite a bit of detail, which is nice. I set the metric to that if it's anything less than or equal to 2% of CPU usage for 1 minute, it would give me the alert. And it does this based on a per host MAC, so that I know that it's happening on an individual node. And I can just acknowledge this. But the other thing there is if you set up your alerts, I'll show you the alert that I made. You can set these up to notification channels. So I have it sending to an email address. And I can also set up these notifications to send to various different things. So I can set up a notification channel to Slack, for instance, which feels a lot more like what we would do. And I was talking earlier about PagerDuty. If you're using that tool, you could hook this into PagerDuty. The simplest thing you could do is hook it up into email, and that would probably be sufficient.
Looks like there's no Microsoft Teams support.
Not right now. I guess Teams. I guess Microsoft would have to have some partnership work with Sysdig to make that happen.
That said, I would say you could send a generic webhook similar to the other component that we talked about with the Azure Monitor service.
Mm-hmm. And another one that I was going to cover over was you can look at cluster-wide metrics. There's also sort of like alert policies that are more sort of focused on, I shouldn't say alert policies, they're policies as part of the secure piece of the platform. And what I did is I looked at one, sorry, I'll cover over on audit and then I'll move over to policies. But if you need this amount of audit and insight into what's going on in your cluster, for goodness sake, it breaks down individual commands that might have been run, and you can look at these details. For example, the full command line thing that was executed, where, when, how, and dive into this and it'll tell you exactly, what's going on. The one that I really liked was if you were to go in and want to set up benchmarks that test your cluster on a regular basis. I set up this one as a test benchmark, and I can show you what this looks like. it's making a bunch of assurances based on the API server and the scheduler, ensuring a couple things have happened. For example, profiling, and then setting bind address arguments. And in the API server, it's checking whether a number of things have been put into place. And these are audits and checks and balances you can create on your own. So if you wanted to create a brand new one, they can be on any number of individual items. And what I'm getting at here is you can drill down extremely deep to really capture what you're trying to figure out about any Kubernetes cluster from in here. Now, this reaches further than what I've seen has been going on with your typical monitoring and alerting stack that comes with the platform, as well as what we're even seeing in the Azure monitoring piece. You can get as far as your container image scanning, setting policies and rules, which, by the way, thanks to the open source Falco component, there are a number that are pre-canned as well, and you can set things to have allow or deny based on what's going on. I mean, I could keep going, but it's exciting because it's very difficult to get all this amount of things aggregated into one place, and then be able to just randomly pick and choose which ones you want alerts on. And that's why I like the tool, and I still do like the tool.
It's definitely very beautiful. Like I've used Sysdig a bit myself as well. Um, I don't really like to do a cross comparison with anything open source, but in terms of visibility, like there's a lot of detail, almost more than you may need a lot of the time. But maybe you can talk a little bit about what you see in terms of Kubernetes resources like containers and services and events, as opposed to or compared to the nodes and the actual virtual machines, physical machines. Do you get any insight on that side as well with Sysdig, Aaren?
Yeah, you can look at everything that Kubernetes is aware of, or that the nodes are aware of that. But it's what it's doing, because it's pulling this data from individual nodes. It knows about the nodes, but it also knows about what the kubelet's doing on each node. And that's how it's making a lot of these correlations. So that's probably where a lot of the Sysdig secret sauce layers on top of the base sort of Falco agent. And if you wanted to make that comparison, the simplest thing would be you could open up like your Kubernetes, like a namespace overview dashboard, and you could do that right next to your host infrastructure dashboard and look at um, any number of resource consumption. So one of them could be based on your host resource usage, and then compare that to, well, I pulled up namespaces because I know there's a good bit of data in here as well, but you can pull up let's look at CPU usage again, because this is what was driving my alert that I pulled up earlier. And you can make comparisons here as well, but you also don't need to be stuck with these dashboards. You can create custom ones, and then you would share those off to specific teams, which is another benefit here where if, let's say you're in a highly regulated environment, you probably want to have specific dashboards given to specific teams. If you're the operations people in charge of this tool, then you might carve out a dashboard for each application project team, and they could see exactly what they need all in one spot. It's kind of similar to creating your own custom Grafana dashboard, except the things you can drill into are a lot more. They have so much more depth than what most tools can show you.
Absolutely.
So really, I was just gonna kind of show this, and then I'll at least mention that you need to know that this, in order to just run it, it's a daemon set that lands on every node in the cluster, a single pod of the Sysdig agent, and this is the SaaS model. You can do this on premise, but you more or less need to have an individual Kubernetes cluster just for this to do its thing. And I would say if you can handle doing the data send out to SaaS, then it's well worth the effort. And there's probably a number of things you can do to ensure that there's nothing uniquely identifiable in the data that gets sent. Majority of it is infrastructure related. As long as you don't have anything in plain text that might get picked up by the audit piece, where we can look at things like commands and network activity.
Yeah, there are certainly exclusions that you can apply inside of the agent configuration setting to help if there's anything that you're concerned with. But by and large, it's mostly metric data on the
Yep.
monitoring side.
And there's one more piece I wanted to just show off, because I think it's a little bit of an undersung component. I'm just going to pull it up. This is in Monitor. Here we go. Yeah, so the integrations piece. So the basic ones that we're concerned with, because ARO is, a Kubernetes distribution and it runs cryo as its runtime. The most basic ones that you're going to see is things like your network traffic and typical HTTP. But there's a number of other integrations that are even application specific that will pull all that metrics data and aggregate it into this same pool and let you make further correlations for big workloads that you're concerned about. So this cluster, because it's ARO, we're choosing to go with Azure monitoring and funnel logs that way. If this was an OCP4 cluster or an on-prem OCP4 cluster, whether it's in the cloud or on-prem, you could plug in the FluentD component. If you have any Jenkins that's running in your cluster, which many of our customers do, you'd plug in Jenkins. Every time you've got an MySQL, you'd probably plug that in too, and you're aggregating all of this data. And there's even one for Prometheus that you can scrape in and make correlations and further expand on this. And the API as well lets that get even further expanded. You can create custom integrations. Really, there's the only problem I see kind of is that in some cases there's probably an information overload initially. And between now and the last time I've seen the tool, I've seen that what they've done is taken some of the most important dashboards, pre-can them so that there isn't as much digging and searching going on the first time you open it up, which is a good thing. I'm open for Q&A at this point, but otherwise that's all I kind of wanted to show.
Yeah, thanks a lot, Aaren. That was great. I think we'll leave it for the end of the discussion in the chat. So right now it's 2:17 Eastern time. We've got a few minutes left. I'm gonna introduce Michael Cardy again. So welcome, Michael. Thanks for joining us today. We're happy to have you on board. For those of you that don't know, Michael is the chief technology strategist in Red Hat in Canada, and he's sort of responsible for helping clients and partners understand Red Hat's goal and helping them understand where open source technology can come into play. And so he's the guy who's very much responsible for explaining Red Hat's vision to clients and partners. Welcome, Michael. I'll let you introduce yourself.
Sure. Thank you so much, Chris. And again, thank you, Arctiq, for inviting me to this great event. I've actually learned a bunch of stuff, and I have to give some kudos to Shea for making a Battlestar Galactica reference in the middle of a seminar. I haven't heard that one in a while, but who would have thought the future looks like the 70s? And that's a fine vintage of show. Yeah, so I'm a former global CTO. I am a chief strategist, so I'm responsible for helping our customers monetize their investments in Red Hat technologies and capabilities, and working with my partner ecosystem, such as Arctiq. And I also run a number of the application development solution architects across Canada that would help our customers, look at different options for OpenShift and how it's to be deployed. And so I have the pleasure of leading that team as well. And thank you so much for the opportunity to speak today.
So Mike, hey, nice to see you. It's been a while.
Good to see you. I know.
So if we take sort of the topic off the top, which is being the Microsoft partnership, right? I might want to go a couple of different directions in our conversation, but the Microsoft partnership, what do you seeing as people are now evolving into sort of the managed service below the, below the application, and kind of how their goals are changing from maybe 3 years ago when we were setting out to like just get the thing stood up,
Yeah.
and sort of the driving force behind the partnerships with companies like Microsoft. But what's that bringing to the table as far as Red Hat's customers?
Yeah, I think there's a few strategic decisions that customers now see as really viable ways of running the entire operating model. One is customers who may be at the beginning of this journey, trying to get a handle on, how do I get something to production as fast as possible in a containerized fashion, and a lower barrier to entry, as we say in economics, I guess, is, ARO as an option for customers. Not a lot of upfront cost. You can defer, getting your teams and your people skilled up so they can properly operate day 2 stuff that we talked about today. And so I think with OpenShift being 4.3 on ARO being offered now, a lot of clients see that as an option for getting going and allow them to buy some time so they can get their operations teams up to speed. Or maybe they're launching a new service that's going to generate revenue for the company, or deliver a new service to the public sector, and you have to get something out quickly. I think COVID's a prime example of that. I think this is an excellent way to deliver value for the organization by looking at OpenShift on ARO and get you to production a lot faster. And a lot of organizations may have some credits with Microsoft that they want to use up, right? And this is an excellent way to take some of those credits and start to play with the technology and see how it fits into their operating model. Other organizations that are further down their journey, they've realized that maybe they need to extend the capacity of their operational team, and they just want to look at Microsoft and Red Hat together. We've been doing this now for over 2 years as part of their, extended teams to operate the environments and allow the organization to get things to production as quick as possible, because nothing delivers value until it's in production, as we say.
And I don't know if you witness this across a lot of your customers, but in my experience, and kudos to Red Hat for figuring this out when they did with Microsoft specifically, was the hourly billable model, because I haven't seen the procurement challenge get fixed in the last 3 years of doing this. So the second we know that we need more, it's too late. Right, like we're into a 6-month or 8-month procurement thing to get the servers on the floor, to get the licenses, to do the year sub procurement, right? Like, and all of those things need to align. It feels like even 3 years ago, I remember talking to Red Hat about this, and we couldn't figure out the hourly billable model. Like it just was really hard to get. But somehow you guys figured it out with Microsoft, at least, where now it's like you can spin up a cluster and be paying for it without actually having to call anybody. And I think that's very, like, you could do it after this webinar, and you could go ahead and do it, and nothing would really be blocking you from doing it.
Yeah, certainly.
So
certainly, go ahead.
Go ahead. No, go ahead. Finish your thought.
I was just going to say, you could argue one of the prime values of the public cloud is the elasticity and being able to scale and shrink based on dynamic demands. This is an excellent way to very quickly ramp up and ramp down. One of the CIOs of one of the big 5 banks in Canada said to me, he says, we're in IT, we're really good at ramping things up, not so good at ramping things back down when we don't need it. And so it's an excellent way to leverage the elasticity of the public cloud. And again, for organizations that are trying to align like revenues to expense to understand their true profitability, the metered approach to expenses really helps with aligning those two things together. So you understand your position, and you don't have to lay down a whole bunch of upfront capital before seeing any value from that investment. So I agree. I think the metered is a key thing as well, especially in the public sector too. The procurement processes can be very, very heavy and reduce the velocity of delivering value to production. You can get around that.
Now, you mentioned when we talk about speed, especially in value, you mentioned COVID. And I certainly know with one of our joint customers, we saw quite a fast demand for. We already had an existing platform, so that was great. But then we were still rubbing up at the edges of the capacity, and ARO is the next step for us. What have you seen across the sort of the Red Hat base in terms of response to COVID, and what's Red Hat's involvement been in helping the other organizations sort of move quickly and respond quickly.
Yeah, well, certainly in the public sector space, ministries of health at the provincial layer and even Health Canada at that layer, the ability to ramp up quickly services to help the general public is unprecedented. I think in April alone, one of our mutual customers ramped up 10 production apps around COVID in the month, and a number of those were done in days. And this particular customer, prior to OpenShift in general, and prior to taking this DevOps Agile approach to doing innovation, that was measured in years, and now they're down to literally days to production. So I think combining ARO with OpenShift, it's just an amazing story to help agility, I guess is the word I'm looking for, agility, being able to very, very quickly turn and pivot to respond to something. It's quite remarkable. I know on the private sector side of things, organizations that were trying to figure out how do we operate this massive IT infrastructure when I can't go to the data center and do my day-to-day operations. How do I do that? Well, I got to go to public cloud because that's all taken care of. It's all programmatic. So, and particularly I've seen private enterprise and public enterprise look at, how do I take this infrastructure as code and really use that to codify the entire operating model of a company? And I think now that you saw today with Phil's presentation around, using Tower to provision ARO clusters, et cetera, we're now at the stage where we can do that. And from an operations perspective, typical operations people don't think in a programmatic mindset. They're not developers by trade, right? And so looking at ARO, this allows an organization to start to get into the infrastructure as code and get their operations team to come to a mindset of development so that they can do declarative-based deployments and ongoing configuration management using Tower and OpenShift. So that's the other thing I've seen. Organizations realize they need to move fast, they need to use automation, and they just consider ARO as an asset in their arsenal for rapidly deploying new services.
Have you, how fast do you think operations teams are picking up what I'm going to title that so I'm stealing from somebody, but I liked what he called it, the infrastructure software developers is kind of the, instead of infrastructure as code or whatever, like the role that they're filling is kind of that role. Are you seeing a rapid uptake in that world in GitOps, or is it kind of still trying to catch?
I think we're still at the early stages of that journey. If I look across all the industries I support anecdotally, and as part of the chief team worldwide, I hear it from my fellow people right around the world, my peers. I think we're starting at the beginning of that. I think, I do have customers running ArgoCD, which you referenced, and running production-based applications, and everything is written as code, and they've separated the data from the actual code that does the configuration of any asset in the entire stack, and they've been successful in doing that. But I think we're at the early stages now. I think organizations that look at enterprise automation as a strategic capability and see ARO as part of that strategy, those organizations are making the proper investments in the people, the process, and the technology all at the same time, bringing on an automation expert and start to drag the rest of the organization to a point where they're comfortable writing YAML scripts, et cetera, to do the actual infrastructure as code or infrastructure software. So we're at the beginning stages of that. I think organizations are slowly going down that path, either going by one domain, like networking or servers or storage, or maybe CI/CD, and then they're eventually once they make that decision to go enterprise-wide, that's when they start to instantiate a dedicated automation team, so that team can learn the way of doing proper build and release management, and then expanding that or extending that out to the broader team through the organization.
I like how you call it build and release management, because that's what it is, right? Like we talk about change control, but it's build and release management for infrastructure software, right? I think it's just a slightly different mindset.
Yes, that's one thing we've learned. You mentioned Ansible in one of the presentations. I think, Phil, you talked about it, but we realized within Red Hat, we've been positioning OpenShift and Ansible in the market, and we're market leaders in both. But we've realized that the approach to how you deploy and provision and doing ongoing configuration management of systems is a development approach now. And there's a lot of commonality between putting both platforms into the environment. You're almost taking the same approach, Obviously, maybe different specific code that you're going to use, but it's the same construct, the same instantiation of, making it programmable. And so you have to build a team around that that's got those skills, and then start to convert people that are normally interfacing with GUIs and command lines and turn them into coders effectively in the operations side of things.
It's certainly an interesting transition for a lot of teams and a lot of investment. But, I think a lot of us came from administrative backgrounds, and we still have internal jokes and debates about SSHing into the machine. And then I come over and slap people's hands, right? It's a fun world for us. I'm curious, like, unless the other guys have questions on these topics, I was a little bit curious about, it's been a little while since the IBM acquisition.
Mm-hmm.
I'm curious what you've witnessed in that change with the go-to-market around something like OpenShift, and how your customers are perceiving the acquisition, and what Red Hat's learning from, I guess from that thing. Either, it could be nothing. I mean, it could be like you just are two separate businesses, or there's actually some synergies that are happening between the organizations.
Yeah, certainly. IBM has stuck true to their word to keep Red Hat as a separate organization with its own processes, people, and systems. And they've really stuck to their word. We had to remain neutral in the marketplace because we do work on non-IBM platforms. Mm-hmm. It's a very important part of a business. And of course, IBM wants the return from $34 billion, so they want to maximize their target addressable market. But at the same time, I think we've learned that from IBM that, their deep vertical expertise, their large benches, that together, I think customers are enjoying the fact that, they can do really big projects that sit on top of Red Hat platforms and can deliver value at scale. Definitely that has really helped the two organizations work together. And it's been through all our partner ecosystems. I have customers that transact business through, organizations that are non-IBM partners, but the actual IBM part number goes through the partner to the end market, to the end customers. So they've been a real great part of our ecosystem in delivering vertical expertise, business expertise, and thinking about things at scale and helping customers transition to a new operating model.
So they're it sounds to me like they're bringing somewhat bigger challenges to you, and the way you guys operate is like, well, you're applying the stuff you've already had. It's just helping accelerate their bigger challenges as well, which sounds beneficial.
Well, certainly, IBM is a massive company, with an $80 billion market cap. And so big customers feel comfortable dealing with bigger suppliers. And so we're part of the IBM supply chain. So we've been able to do bigger deals, and we've had a very successful run over the last, it's just a bit over a year. I was on a boat in Greece when the actual transaction happened with IBM, and we became part of the IBM family. I guess we're cousins to the IBMers, because we are kept separate. But so far, it's been very successful. We still, in areas, we still compete, believe it or not, with our owners. It doesn't happen very often, but I think OpenShift has become the de facto container platform for any IBM software. And so it's been a rich, good on both sides.
So maybe if we go a different direction and talk about nerding out on OpenShift a little bit. I mean, massive change, right? Arctiq's 4 years old. We were around in sort of the OpenShift 3 days, which is, I think, when really OpenShift took off, right? Like the bet on Kubernetes was the thing that made it sing. I was never involved. I think I was trained, but never involved in anything OpenShift 2. And now we're in 4. 4.5 is, coming out. I'm looking at some, feature releases for 6 and 7, 4.6, 4.7. What are you excited about coming up in terms of both the tech and the way your customers are using the tech? Because I like the tech, but like how the customers use it to me is what's really, valuable.
I think there's a few really exciting things. Number one, Windows containers coming out and being supported on OpenShift. We do have a lot of customers that have a traditional Java house, and they also have a Windows side of their business, but also pure Microsoft organizations. They're coming to us saying we love the opportunity for density by running, .NET applications in a window container on OpenShift. And there's strong business cases around that we're working on. And so we've done a lot of pilots or proof of concepts around that. So we truly have a unified control plane that is OpenShift across the hybrid cloud for all workloads. Linux and Windows probably making up 97% of the operating systems on the planet. And so we finally got to that point where we can run any container-based application, whether it's Windows or Linux-based, on OpenShift. That's exciting. I think the idea of finally leveraging service meshes and being able to build applications that are designed for change through either microservices or distributed-based application architectures, and using service meshes as a control plane has been massive. I think with the public cloud providers and much more deep integration with some of the tools like you showed today around monitoring, I think that's really starting to mature. And so, I think the opportunity for customers is to have one way of innovating, no matter where that workload ends up being, on-prem or in the public cloud. And it removes duplication of assets, being people and other technologies, and you only have one remove duplication of processes and technology in general. So I think it's we're sort of converging to a point where everything is optimized from a cost efficiency, a time efficiency, and from a risk perspective, by having one platform that can really suit any type of workload, be it on Windows or Linux, or some of the new emerging workloads like AI, ML based workloads as well. So I think we're at the stage now where people can responsibly take or receive benefits from a hybrid cloud model on OpenShift.
Yeah, one of the things I don't think we've touched about, but is the Red Hat Advanced Cluster Management, which is looking pretty cool. I think it's kind of in tech preview or coming out, but yeah, that's kind of giving the ability, the multi-cloud kind of has been talked about for a while, but I don't think with OpenShift there was a really good solution to do that. There was, that kube-fed thing for a bit, and then getting people to, run your own pipeline to deploy to multiple clusters. But then, as an ops person, you're stuck, maybe that on-prem cluster is something that needs to stay there. But then you've got your flexibility on the cloud. And now you're kind of operating two clusters at the same time and applying the same rules. So yeah, that the advanced cluster management seems really promising. I haven't played around with it yet, but yeah, having, one place to potentially manage multiple clusters, set policies in one place looks really powerful.
Across Kubernetes,
I think
distributions. Yeah, absolutely.
Yeah, I think it's really clever that it can be plugged in to any Kubernetes distro. That's interesting.
Yeah, I agree.
I think it's also interesting that it shares an acronym with another product of the same acronym, ACM.
Yeah.
There's only so many letters, man.
Yeah, exactly.
Gotta do what you gotta do. You can't be in charge of marketing, right?
Yeah, it's hard to foresee what other people are going to use for branding, and certainly there's overlaps in the IT industry and branding because acronyms seem to run king. So, yeah.
Well, that's so. I think we're also seeing a lot of organizations chasing the same things, right? And so you take a look at continuous delivery, right? Your ACM, the Advanced Cluster Manager, is going to have a component of that. You're going to have Argo. You're going to have Flux. You're going to have I think this is actually a really hard thing for organizations to wrap their head around, and this is often why they look at somebody like Red Hat, is because I think they're saying, can you please give us an opinion? And Red Hat will lay down an opinion. Yes. And they'll kind of wait for the marketplace to settle out a little bit, like, what's the pipeline tooling that I should be using? And it's really difficult in the open source world without a supported option, without something that I can call somebody for help on, to pick which way I want to go. And I think some enterprises still struggle with the, do I support it myself and build it myself, or do I wait for the vendor to provide something that they know that they can support, and at a wider range, I know I can open up tickets on and feel like I've got somebody's got my back. And I feel like the whole Kubernetes ecosystem has continued to make that a harder decision for a lot of customers.
Yeah, certainly with the number of Kubernetes distributions out there that you can purchase and customers look at, and the myriad of tools that are required to actually make a Kubernetes cluster actually do something useful. And that's why OpenShift was created. The main purpose of OpenShift when it was originally created was just to allow developers to get stuff to production, and no offense, but to get everybody else out of the way, and to embed in the platform through policies, ways to protect the enterprise and the developers themselves. But that's why it was created in the first place. And I think Kubernetes itself, it's kind of like the kernel in the Linux operating system. Sure, it has a function, but it's only part of the picture to get a rich development experience and to get things to production as quick as possible. One of my customers looks at, workloads running in OpenShift on ARO today, one of our mutual customers. And, they're like, when we deploy an application inside a container on ARO, the application inherits high availability, disaster recovery. It inherits all the features around performance logging and monitoring. It inherits auto scaling. That's all embedded directly into the policy of the underlying platform being OpenShift. And you don't have to call your operations team when you need to do high availability or DR. It's just inherent, and it's just like object-oriented programming, where the object inherits the capabilities of the attributes of the class. It's exactly that. So organizations are really starting to understand that the way that we run and operate our companies is changing rapidly, and the platform is doing that automatically under the covers.
I think it so here's where it wins, is that I think it fixed what the virtualization and OpenStack world and everything else kind of didn't succeed at, which was making access to the infrastructure easy.
Mm-hmm.
And I'm going to loosely say easy, because we've turned everybody into a YAML manifest author, right? And it hasn't come without its own complexity. Like Kubernetes is massively complex, but
Yes.
I think Red Hat did a really good job of focusing on the developer experience first. And I think you would agree with me, in the earlier OpenShift 3 days, it was at the penalty of the operational side of things, right? But now, everybody's moving forward with an operator for everything, which is great, right? We've got these things that can auto configure everything for us. But it has made it complex. I think it's just helped us speak a more common language. So, if almost like in the Microsoft world, if you were to search for a Microsoft error, you're likely to find quite a few results. And the same thing's going to happen with Kubernetes now, where you can almost have the Stack Overflow support queue if you wish. Especially when, there's subreddits on this and things like that, where if you get decision fatigue, you can go that direction. But Red Hat does a really good job of packaging in a well thought out, opinionated solution as well. And I think we're starting to see that with more of the Tecton investment and sort of OpenShift pipelines and things like that, where we can finally start to get rid of some of the other stuff that we've kind of dragged in from our other environments, like crufty Jenkins things. But one thing I think would be neat, maybe it's a product pitch for somebody, is like a 12-factor app health check. And so you do this through a policy controller or something like that, because the platform is inherently highly available, but the development teams often still don't know that a single pod isn't highly available. So yes, it will get restarted and we will restart your workload. But what if we're checking the fact that you needed 2 or 3, and that they were inherently distributed across different availability zones if you're going to be an ARO? I think those types of checks are really, really helpful. And I've seen some of the previews, because OpenShift's been doing a really good job on the Twitch streams for the last, at least I've been on for the last couple of weeks, where they're doing tech previews and stuff, and they're doing little walkthroughs and check marks. And I think if you got to that 12-factor app, like, hey, we've made sure that you have at least 3 replicas, and we've actually enforced it. We won't deploy it if you have 1 replica, or automatically increase it. That's going to get teams to learn how to develop an application that can be scaled, because we're still seeing, I think, other applications being brought into these environments that aren't, able to be scaled. And so, I'm going to click go up on my pod count, but at the same time, maybe my application is actually not supporting that, because I'm not handling sessions appropriately or things like that. So there's still this other developer view that I think leaves to be desired, right? As we move to this complex system, how do I get the check mark to know that I'm actually truly highly available, and circuit breakers are in, and path routing is good, and there's so much infrastructure stitching around this thing that we are passing on to developers, that they can make bad choices as well.
Agreed. Application architecture is so important to allow you to run in an elastic mode and be cloud native. 12-factor is one way of doing it. That is very important. And as I always say, you got to build applications down, from application down. And definitely, application developers have a lot more additional things to think about. But at the same time, the new application architectures, microservices, event-driven systems, but they also we give them within the platform Istio and service meshes and some of those control points to handle and offload and hide that complexity and abstract it out using the platform itself, as well as providing insight to the operations team on application health when it's a distributed application. It's built out in chunks, so security teams can have the security control layer within Istio as well. So I think, yes, we're getting more complexity to the app developer, but at the same time, we're providing the tools within the platform to manage that and allow the organization to instantiate policy in the platform to put guardrails on to protect them against trying to do single pod deployments. I think it's HA. So
exactly.
Right?
Cool. I feel like you've been very generous with your time. Maybe one non-technical question: when we're allowed to leave our homes and kind of do normal life, where are you going first? You said last year you were in Greece on a boat.
Well, it's funny. I got back from Colombia, which is aligned to the name of your OpenShift customer, except it was with an instead of a U in the word. But yeah, I was in Colombia up till the end of January, and I came home. So I just had taken my vacation, but. Yeah, I don't know what I'm going to do. I'll probably end up going somewhere. I love to travel. I do have places in Colombia that I may go back to, and that would probably be the natural next destination once I think we get to a point where we have vaccines and the situation's under control and we all feel safe.
Well, if you haven't met Dave on our team, Dave and I and a couple other people were in Colombia a couple of weeks after you just gotten out. So he's got lots of family there. So maybe we should talk and they can show you what a family dinner is like in Colombia.
For sure, yeah. My spouse is Colombian. She came here in 2001. So yeah, we go to Bogota and have a condo in Santa Marta. So it's beautiful.
Nice.
Yep.
That's awesome.
Great. Well, thanks a lot, Mike, for joining. These were some great discussions, and hope to see you around soon.
For sure, my pleasure. And I will tell you, Arctiq's a strategic partner, and together we're transforming both public sector and enterprise businesses together. And thank you again for having me.
Great. Anytime.
Thanks, Mike. Nice to see you.
Good to see everybody.
Phil, Chris, and Aaren, thank you so much.
Safe, healthy.
Thanks, guys.
Bye.